Hello everyone, this is Mr. B with some Algebra 2 Notes 3.3. This is going to be systems of inequalities. Um, this is just kind of a more applied version of 3.1, so no worries there. We should be able to jump through this here with some ease. I tried to leave as many of these inequalities as straightforward to graph as possible. The homework, there are a couple curveballs thrown at you, but none of them should be ones that we can't handle. So first off, solving systems of equations. To solve system of equations, systems of inequalities, very much like systems of equations, graph them on the same graph. The solution is where the two shaded areas intersect. Make sure to do dotted or solid lines for a lot of these graphs, as that can be kind of a tricky point. Take a point or a half point off on a test or something like that. So just make sure you're aware that these have to be either solid or dashed lines. All right, the first one here, to graph the border line, we're going to go to -3, that's the y-intercept, with a slope of +2. That means we'll get something like, let's see, something like that. I'm going to check a point for this one now. I'm going to say 0, 0. That would give us 0 is less than or equal to 0 minus 3. That's going to check out. 0 is greater than -3. So we'll shade this side. I'm going to keep it really light for now. And then this next one here, slope, or the intercept is at +2. And with a slope of -1, we'll get something like this. And I'm going to check another point. I'm going to check 0, 0. Oh, I didn't follow my own advice. This is going to be a dashed line. All right, good enough. Now we'll check 0, 0 on this one. 0 is less than 0 plus 2. Well, that's going to check out as well. 0 is less than 2. So we will shade this side. Now it's where they intersect. So I would want something shaded pretty heavily like that, a clear indication of the two lines that it's going to follow. Something like that. That's going to be good enough for me. All right, down onto the next one here. When we're faced with something like this, these can be kind of intimidating to start off with, especially when we start throwing absolute values in there. But realize that this type of an absolute value inequality is just going to mean this number needs to be somewhere between -3 and 3. So we can rewrite the inequality just like that. So I'm going to say -3 is less than or equal to x plus 1 is less than or equal to 3. I'm going to subtract 1 from everything here. So we get -4 is less than or equal to x is less than or equal to 2. Then we'll graph that. So any x value, y, doesn't really matter. These are going to graph two horizontal lines. So we're going to graph this one, that line, basically y equals 2, and this one here, I'm sorry, x equals 2, and this one here, x equals 4. So we're going to graph the -4. Let's see, so we'll graph this one here. We'll graph this one here. Any value between. So really it's this whole center that we'd be looking for. But that's not it. We still need to graph this first inequality. Kind of jump to the more challenging, the one that's going to stand out to us a little bit more. We've got a y-intercept of +1 and a slope of -1. So we'll have a line that looks something like this. We'll, of course, shoot off in all those directions. Now we'll try a test point. 0 plus, or what am I doing? 0 is less than or equal to 0 plus 1. Well, that checks out. 0 is less than or equal to +1. All right, so that means we're going to shade that side of this line. So it's going to be this whole side of the line. But remember, we're looking for this inside where they both intersect. So we're looking for something that looks like this. It can get a little messy. If you guys want to erase your other marks, that's totally fine, and then just shade in. That actually looks pretty clean, so I'll do that for this one up here as well. We'll erase all of these exterior marks. That's what we should be left with. All right. And here's another one. This one can be kind of tricky. You might kind of stump yourself on this one, but that's okay. We're looking for a slope with the intercept of positive 3 right here with a slope of positive 2. So we'll have something that looks very much like this. And then we'll have one with a y-intercept of negative 2 and exactly the same slope. So based on what we did with the last 3.1, we know that these lines are never going to intersect because they're parallel. They share the same slope. Let's check the points and see which way they graph. For this one here, we'll try 0. So 0 is greater than or equal to 0 plus 3. Remember, we're checking this point, the origin here. And this is the first line that we're checking. So that does not check out. 0 is not greater than or equal to 3. So we would shade the opposite side. We would shade in this direction. I'll keep that actually. Let me do that one. Redo it a little bit lighter. So we'd shade in this direction. For the other one, the sign is flipped, which we can just kind of make the jump that it's going to shade on the opposite side of that line. But let's try a test point anyway. We'll try 0, 0. Let's see, 0 is less than or equal to negative 2. Let's see. That one does check out. So we would shade that side of that line. We would go in, let's see, looking at this correctly. Oh, that's not correct. I got all turned around in the numbers here. 0 is greater than negative 2. So this one is false. So we would shade the opposite side here as well. What we can see here is because these lines are never going to intersect, there is no shared kind of shaded section. So for this one, well, I guess I'll leave all those up here. There is no solution. All right. If you guys do have any extra questions on these notes, please feel more than free to ask us. These can be pretty tricky, especially when we're dealing with graphing inequalities, something that's still fairly fresh to us. And now we're graphing multiples and having to overlay shaded sections and things like that. So feel free asking us. That's totally okay. All right. We'll see you guys next time.